Okay lah, I don't know whether I did well or not.
Well, as long as you are okay with the test, we'll see how it goes.
Okay.
Have you done this question that I asked you to do?
74.
I text you already the day before.
Yeah, number 3, right?
Just want to make sure you know how to answer long structure question.
I only managed to like do here and there only lah. I can't do like
How
fully.
can be like that? You must make an effort to do the question. If you don't learn to do it, you are going to be in trouble. You're wasting your money taking tuition. Okay, let's go over.
Okay.
Found a page, number 3. Focus, number 3. Long structure question.
Yeah, the essay one, right?
Must learn to answer the long question. What is meant by time constant of a discharge tube, discharge circuit of a capacitor? Yep, can remember?
T equals to RC, right? That one.
No. That one is a part of it, but it's not completely the definition.
Oh. Time constant of a discharge circuit, I should say that
all this must be in your head. All right.
1 minute, Archer. Yeah, hello, Sir.
Yeah.
Yeah, okay.
It's the time constant is the time taken for the current in the circuit to drop to 1
to discharge
of the initial value, right? And it's equals to RC. That must be in your head. That one to gain mark 1 in exam. All this must be memory work. You must score.
At least the definition can get marked lah.
That one must score. That one must memorize it. One way to memorize is keep on doing question, then write it down without looking at it. Discuss qualitatively how the time constant of the discharge circuit is affected by capacitance of the capacitor. Yep. How is affected by capacitance of capacitor?
How the time constant of a discharge circuit affected by capacitance of a capacitor? This one, can I say like the something like this one increase means that one decrease? Can I say like that? No, right?
You have to elaborate a bit more. Maybe explain a little bit more, because it doesn't want you to be using a lot of maths. It wants it to be helping you to understand why if you have a large, why it's affected by capacitance of a capacitor. Yeah, not just this formula, but understand why this formula works. That's qualitatively. Can? Okay, for large C, the time constant is larger or large. For large C, it store more charge in the capacitor, so it take more time to discharge. That's what I mean. Right? More large C can store more charge, so it take longer time for it to discharge. How about resistance? Right? The formula tells us larger resistance, greater time constant. So how do you explain that?
For large resistance, the time constant increases.
Yeah. Why?
Why?
Hmm.
Because the conductivity decreases.
No, nothing to do with conductivity. We never study conductivity in this topic. Same idea. Right? Resistance slow down the discharge. Greater resistance is slow down. It will take longer time for the capacitor to discharge. For large R, the time constant is larger. That's what you said correctly. Right? Larger the resistance, larger the time constant. Larger means smaller discharge current, right? Because it slows down the discharge. So the capacitor takes longer time to discharge. Okay.
Okay.
A number of capacitor mark 6 microfarad, 3 volt maximum are available. Draw diagram to show how the capacitor should be connected to a 6 volt battery in
In order
order to
to
obtain an effective capacitance of 2 microfarad. How to do that?
okay, effective capacitors mean that means they campur two, so that means we can separate one UF and one UF. So this one, you can do parallel, right?
Why parallel?
Parallel or series, I think I'm not sure, but like you connect the 6 volt battery and then you put below or above, and then the other line there you put capacitors lah, like divide it into two capacitors.
It cannot be parallel. Parallel, it means you have to add up. Right? All this info must be in your head before you can answer this. It's parallel, you add them up. So you will get 18 if it's 3 of them in parallel. So it must be in series. Right? And then you have to make sure it doesn't exceed 3 volt. So you put a voltmeter there. Sorry, you put a power supply 6 volt there. Then each of them will be the same. Each of them will be 2 volt, 2 volt, 2 volt. So you are less than the critical value, that maximum that it can work. If it's more than that, the capacitor will break down. That's the idea of working voltage. Okay?
Yeah, 6 divide 2, right?
No,
6
6 divided
divide
by
3.
3. 6 divided by
Yeah.
3. Yeah, remember
But then
capacitor.
they say 2 what?
Yeah, 2. So you put it in
Okay.
series, you divide by 3. So it's 2. That's why I say you must do
So
your
it's not like
homework.
you campur 6 plus 6 plus 6 and then divide 3.
It's 1 over 6 plus 1 over 6 plus 1 over 6. That's why I say
Okay.
you
So
must
it's
do your
a
homework. If not, you
parallel 6
forget
plus.
everything. That's why I say you are not understanding what is happening because you don't study. Right? Make sure. Yeah, still early. Busy, you cannot study last minute one. You have to do the homework. Then it becomes part of you, like maths. Right? So where 3 of
The
them,
maths more harder lah.
that's harder, but physics is also can be harder because you don't know how to use the
Oh,
formula
more
if you
harder.
don't start doing it.
Maths no need to think lah. Just formula only.
Same one, physics a lot of formula. If you don't know how to use it, they twist it there, twist it there, twist it here. Then you will get lost also. It's just like English, getting you to understand the definition and then how to apply it. But physics is a lot of formulas that you need to know how to use it. That is your definition. And they do twist it around.
Yeah.
Okay, so it's still early. You can still do it. It's not that difficult. It's just that a lot of sometimes we find it hard because there's a lot of
Oh,
definition.
did I tell you that for this 1 month I'm going to be in the house only?
You'll be in the house is better because the COVID is spreading.
No, that means I got more time to study now lah. Like
Hopefully
now,
you put in the effort to study. Okay, the next one, 6 microfarad. How do you get
yeah.
that? Yep. Condition is it cannot be across there 6 volt. 6 volt, the capacitor will spoil. That's why you cannot use just that one single one. Single one, the capacitor will be damaged with 6 volt. Yep.
6 plus 6 plus 6 divide 3.
So you already got that. How should you do? How should you connect it up? Yep. How should you connect it up? Six plus six is 18. So you need to divide by 3. So how are you going to do that?
Yes.
Yeah, the answer is just there. If you put in series, you get 2. Then you put in parallel. Parallel like that.
Yeah. Am
I right? Have I done correctly?
Yes. Go back again.
Yeah, is there? 6.
No, I mean go back again to the answer just now, the previous ones.
6 in series. 6 in series will be 3. 6 divided by 2 is 3. 3 plus 3 is 6. And across each will be 3 volt. We just obey the instruction. 3 volt. Okay, satisfy the condition. Okay.
No, I mean go back again to the some of the answers I didn't get yet.
This one give you a bit of hint already. This one give you a bit of hint already. You have 3 of them in series. We divide by 3. So 6 divided by 3 is 2. That's why we get our 2 here. Yeah.
Okay.
So you can either have another parallel one, but not necessary to have 3 parallel. 3 parallel will be 2, and then if you have 2, this series one, another series one in parallel, another series in parallel, 3 of them, then you still get 6 microfarad, but not necessary. 2 is enough. Right? This one will be 6. So if it's series, it becomes 3. This one also 3. 3 in parallel, you add them up, it's 6. And then use 6 volt. 6 volt, each of them will be 3 volts, so it's okay. You satisfy the condition that is required here. Can? A 6 microfarad capacitor is charged by connecting with a 50 kilo ohm resistor and a 12 volt battery. What is the value of the time constant of the charging circuit? This one is just memory work. First step is they have a simple calculation. RC, convert all to SI unit, right? R 10 to the power 3, 5 to 10 to the power 3, and then C is 6. Sorry, 60, not 6, 60. 60 microfarad and 10 to the power minus 6. And get it out. 3 seconds. Find the potential across the capacitor 1.5 seconds after the charging starts. So this one you have to memorize the charging formula. Can you remember or not?
V equals to IR.
Say again.
V equals to IR.
V equals to IR. No.
No need. V equals to, because we already have the time and the resistance already, so
I can see that you are not prepared because you didn't do homework. This is a formula you need to memorize.
yep, that's the
You know how
formula.
to use it. This is for charging. That is the initial voltage there. Then put in your value.
Wait, isn't the E equals to VO actually?
Yeah, you can call it VO if you want to.
Oh,
Right, I
okay.
call just E. Yeah. So 12 volt, that must be 12. Time constant, put it there. And then you are told 1.5 second, put your 1.5 second here, and then calculate. That's all. So you get 4.7 volt. Do you have a printer at home?
Got.
Okay, I've sent you the note. You can print it out and try the question. Or print it out and
You
then
mean extra question?
I give you the note. Right? If you want to follow it, you can download the note.
Okay.
And then the question you can do on the paper, on the note itself. Then you can follow easier rather than on your handphone. Calculate the current in the circuit 2.0 second after the charging starts. Yeah, how you can calculate that? You can see this topic you are not very prepared because you don't do your homework. You don't know what to do. You are lost. Right? I naught, how to calculate your I naught? I naught is determined by that initial voltage and that capacitance. So I'm using that 50 kilo ohm and 12 volt. So this is supposed to be kilo. So I get milli, 0.24 milliampere. Then the
V over
formula,
R.
whether it's charging or discharge is hard because you never do homework. That's why I've been scolding you last week. Because you don't do your homework. Then you see more stars as you go further. You cannot do physics by just reading, because there's so many formulas. Right? Put in your value, that's all. Right? This one is milliampere. You will get milliampere as answer. Your time 2. Your time constant is 3. Put it in there. Right? Calculate out. That's your answer. Okay.
Yeah, okay.
Okay. The others you can try out yourself. Make sure you do your homework. If not, you will see more stars.
Stars.
Yeah, because you cannot understand what is happening.
Oh, okay.
That's what it means. Okay, let us go to electric current. New topic. I've sent you already the note.
So this one, I mean, this teacher go through very fast, like we don't even understand. I mean, we weren't even concentrating because he just
Doesn't
went
matter,
through.
you have a tutor here, so you have to make the effort to study. The book is there. Your revision note is quite good. It's as good as textbook. I've gone over it, so I know. So we are going to cover.
Wait, then the SEM one, the other book.
SEM 1 is also good, written by the same
Oh,
author.
but we never do the Oxford one, what?
Doesn't matter. Both are the same author. Both are equally good. It's just that you don't do the homework, that's all. That's the reason why you are very poor in physics. You have the book. You have all the goodies there, but you never take it to do it. You never Like you have all the food there, all the good food there. You don't know how to enjoy because you don't try it. Same, the book is as good as textbook. I've gone over it, so I know. If you have tried it, you should be able to do well. Okay, anyway, we are going to conduction of electric current, topic 14, conduction of electricity, drift velocity, current density, electric conductivity and resistivity. So some of these you have studied before in your SPM. So let's go to conduction of electricity, page 77. Right, you have downloaded the note, then you just refer to my note. If not, you can refer to your book. Right, syllabus wise, under conduction of electricity, there's a definition. Right, define electric current using the, and then how to use the equation to do calculation. Explain the mechanism of conduction of electricity in metal. Right, how is the conduction of electricity in metal by electron? Okay, that is your previous topic. We study about electrostatic. First topic, we study about electrostatic. And in electrostatic, we study charge at rest. It's not moving, it's stationary. Then we study about para-conducting plate, where we connect to a battery. We have electric field, and we use that electric field to either accelerate a positive charge or accelerate a negative charge. In this topic, we are going to look at the charge itself that is moving, right? Is electron. Previously, we can look at positive and negative charge, but now we are going to look at electron moving a conductor. And we know that for a charge to be accelerated, you need an electric field or a potential difference across a conductor, right? Across the plate here. There must be a potential difference across the plate to produce electric field. And then the charge is accelerated. So in this case where we study about electric field, usually we don't worry about the air, we work it in vacuum so that there's no collision. But in metal, we cannot. There will be collision. So we cannot use the same idea to study. Right? So usually the electron will be moving in vacuum. There's your power supply, different type. Right? There's your lead acid accumulator, power supply in different lab. There's your dry cell. Right? We call it DC power supply or PSU. DC for direct current. Variable supply unit. Right? These two allow you to choose your voltage. This one is fixed, cannot change. This one also fixed, cannot change, fixed value. Right? This is your lead acid accumulator you find in car. So recognize the symbol. Right? There's a symbol for dry cell. And then there's a symbol for power supply. This one, either these two. Right? Let's look at the first thing that we want to define, sources of EMF. In this case, we have a dynamo or generator where we convert mechanical energy into electrical energy. How do we do that? We turn this one. Right? We will study this in under magnetic field. We turn this one, mechanical energy here. Right? So as it turns, it generates electric current, alternating current. So we got
Electrical energy.
here that's produced. Right? That's your SPM work. We'll study more detail later. So we have mechanical energy converted into electrical energy. Right? And we have also other source of EMF. Right? That's your dry cell. Convert chemical energy into electrical energy. Inside there will be chemical. So as you connect a wire across that, then it causes chemical reaction. That's why you got current flowing. And we got solar cell, which is getting more popular. Sometimes you put it on rooftop, or you can see a big field there with this solar collector. Right? Basically convert light into electrical energy. And then we come into, when we study electricity, we have to know that there are what I call conductor and insulator. We can test it, right? Like in this case there, you use a paper clip. Then we see that connect to a battery, connect to a bulb, we see will light up. That means current will flow. Or we have a insulator here, plastic, no current will flow. So we know there are two things you need to know: conductor and insulator. Conductor, current will flow. Insulator, current will not flow. Okay, of course, we will never connect a wire directly there. Right? This one is for illustrated purposes. We have a simple circuit. This is your cell. You can think of dry cell, and there is your wire. So when you connect it up, this terminal is positive, this terminal is negative. So that is your electric field. The wire channel the electric field there. Okay, so the battery or voltage source, there's a battery or voltage source, maintain.
Can you go back again, if you don't mind?
Go back where? This is where we are starting.
No, go back again, sir.
Make sure you print the note out. If not, you keep on going back. Print out the note I sent you earlier.
Sir, too much to print, sir.
Too much to print, then you not need a computer.
Yeah, I got a computer. I got.
Computer and handphone, and then download into your computer. You can use two at the same time.
Yeah, okay.
You can print one page, four of them together. Okay, so the battery maintain a positive terminal, negative terminal, and that is your electric field in the wire E. Right? The voltage source or the PD source provide the electric field in the wire. So always remember, the electric field will start from the positive terminal, go to the negative terminal. It means it points towards decreasing potential difference. And usually we say it drives a current. Right? Usually we don't bother to put a term conventional. Right? Current means conventional current already. Right? So it drives the current through the wire from positive terminal to negative terminal. Right? If you want to look at the actual current, then it is the electron from the negative terminal that accelerate against the electric field and go to the positive terminal. That is the actual current. So you want to say current, electron current, you have to differentiate it. If you say current, it means electric current, conventional current, full of positive charge. Okay, so 10 minutes time, we have to change your new Zoom. So the first thing we have to tell you what is electric current. This is not a definition. This is tell you what it is. Physics, we always will tell you a definition so that you understand clearly what it means. What I mean and what you mean, what you're understanding, and now how to use a formula. Right? Rate at which charge flow through a cross section of a conductor. Right? Rate at which charge flows through a cross section of conductor. Right? For study current, we just call electric current quantity of charge divided by time. Right? If you study current, it means the current is constant. But when we come to rate, it's always dq dt. That's what it means by rate, not q over t, not ratio. Right? This might give you an impression that it's q over t. No, it's not q over t. This is only for constant current. We can use that. But if the current is changing, then you have to use dq dt. Right? Remember, it's a rate, not a ratio. Unit charge is in coulomb, time is in second. So unit of current is coulomb per second, and we give it a special name, ampere. So 1 coulomb per second is 1 ampere. Okay?
Wait, 1 minute, answer.
This is your SPM work.
So,
Nothing new.
I forget very fast. I'm not the expert.
Review. Next time review your SPM book. You still got your SPM book.
So it's related lah.
It's related. They
Okay.
go more deeper, that's all. What you have studied
Okay.
before, they will still go through, but after that we go
Teacher,
into more detail.
teacher, you do notice, right, that in case I go university, I'll be learning the same thing actually, this one.
University is more and more new things already.
No, because they say first year is similar to STPM. That's what they said.
Is it? Oh, okay.
No, but that's why they say the first year of your degree year will be like easy. Then after that only like okay,
Oh,
a
that will
bit
be
it'll
easy
go a
lah,
bit
first year.
harder.
Then
That's
become
why they
harder.
say STPM student will rest, the matric student will suffer. That's what they said.
Okay, let's go away. Good lah. Then it'll be easy the first year. Same lah. Overseas university, the same thing. First year is easy.
Because STPM learn everything already, but the first year one.
That's why you get the advantage of you do a harder course. Right? For electric current in copper wire, the charge carrier is mobile electron. Right? What is the one that's moving? Electron. We call it mobile electron. And
Electrons
the
are moving.
positive charged copper ions. Right? That means the positively charged copper ion. Atom losing a charge. Stationary in the metal lattice. Right? It doesn't move. It's stationary. The positive charge. So whenever we say we treat electric circuit, usually we use conventional current. We never discuss electron current. Usually we say it's positive charge that move. Right? Even though the truth is electron that is moving. We quite conventional because we agree. We agree to say that it's by rule. Right? Not the truth, but that's by rule. We all agree because scientists have been used to using electric current as flow of positive charge, so they prefer to keep to the old idea. Now, you want to say electron current, then you just specify electron current. So whenever we say electric current, then it means conventional current. Okay? Nothing much. This is your SPM work.
Wait, conventional current means what again, sir?
Just decide. You and I decide. It's a flow of positive charge, even though it's not true. Scientists decide it's a flow of positive charge because they are so used to thinking of it as moving a positive charge.
But they don't know the real one.
They know the real one. It's just that they are so used to it, so it's easy to say.
So they can't deny that lah.
We decide by rule. You agree, I agree. So when you want to actual current is a flow of electron. Then you have to say flow of electron.
Okay.
So whenever you say electric current, it means conventional current. You just have to imagine it's the flow of positive charge.
Positive charge.
That's all. So read through the note first. Read through the note before you come. Then you will be more prepared.
Okay.
Oh
yeah, maybe that was my mistake.
So that is for constant current. You can draw a graph. The current doesn't change with time. So what does the area under the IT graph represent?
Yeah,
what does the area under the graph represent? I times T, what does it represent?
Power. Wait. No.
This is your SPM work. right? The area I times D. Use your formula to
So V
understand
lah, potential difference lah.
total charge flowing during a certain time. This formula. There is a definition. Cross multiply.
Wait,
Become
it's not
integration.
V equals to IT, ah.
Yeah. I times dt is area under the graph. You must be understand the calculus notation. dq equals to I dt. Area under the graph. So it's the total charge flowing during a certain time. Okay.
Okay.
Okay. Since you have downloaded the notes, you can try the next two questions, 14.1 and 14.2.
Oh, the one you send in Gmail, ah. Okay.
Yeah. This is just application of the formula, that's all. 14.1 is there, 14.2 is that one. You try that.
Yeah.
You want to take a short break, go ahead, but don't take too long, right? Because I have to start a new Zoom, so I will close it now.
Yeah, within 5 minutes lah.
I still give you work to do, so it's up to
Yeah.
you to take a short break. You want to go to the toilet and then do your two calculation. Okay, I'll
Okay.
stop here.